And the next piece about fluids, we're going to talk about pressure. Pressure is nothing other than force per unit area. So force applied over an area. And so if you look at where this comes into play, if you're poking someone with your finger, that's a relatively small force over an area that's this, about probably a square centimeter or so. But if you're applying the same force and you're using a needle, the pressure is much higher. And as you know, the needle will go in while your finger won't go in. If we look at other units for pressure, the Pascal is the one that's the standard international unit for pressure. One you talk about all the time is PSI, pounds per square inch. Well, um, it's about 7,000 pascals to 1 pound per square inch. And the other we talk about all the time is atmospheres. And there it's about 101,000 pascals per atmosphere. And so, relating these to common units, the SI unit to common units, 6,800, 6,900 pascals to 1 psi, 101,000 pascals to 1 atmosphere. As you know, pressure goes up as you go down inside of water or inside any fluid, the pressure goes up. And the pressure goes up as you go down as the density of the fluid times the acceleration of gravity times whatever depth you're at. Here it says H, but whatever depth you're at. So for water, that means you're going up, you know, every 10 meters or so, you're going up about 1 atmosphere. So if you go down to 10 meters in water, you're at about a total pressure of about 2 atmospheres because you've got the 1 atmosphere of air on top of the water plus the 1 atmosphere of pressure from the water itself. All right, and so you got the air on top plus the water itself. And so when you get down to about 10 meters, you're getting close to being at a total pressure of 2 atmospheres. And that's really important if you go to scuba diving and things like that, because that means that your body is made up mostly of incompressible fluids. So your body's mostly water, that's not compressible. Your bones and all of that, those aren't compressing. Um, but the air in your lungs has to be at that 2 atmospheres for your chest to expand, right? Otherwise, your chest isn't going to expand. So when you're breathing underwater and you're at 10 meters under, you're breathing in and you've got a greater pressure that you're breathing in. If you're going to be much deeper, then you have to begin to worry about the partial pressures of the different gases you're breathing in and whether or not you're getting the right amount of oxygen. And so when you go to greater depths, you actually begin, or if you're under for a long time, we actually begin to decrease the amount of oxygen that you're breathing. Well, actually, we're keeping the amount of oxygen you're breathing the same, but then now the oxygen has much less volume, and we have to fill in the rest of the volume with other gases that don't matter, right? And so it's not that you're getting less oxygen, you're getting the same amount of oxygen. It just takes up less volume because it's at higher pressure, right? So it takes up at 2 atmospheres, the oxygen takes up half as much volume as it would at 1 atmosphere. And so you got to fill in the rest of the volume in your lungs with other gases just to be able to breathe. All right, that's it for this piece.